4.5 graphs of sine functions. I broke this up into notes and examples. We're going to first start with the sine function, f of x equals sine of x. To start really with any new graph, we always do a t-chart to kind of get a general idea of what the parent function is going to look like, and that's what we're going to do with the sine graph as well. So we're going to go back and look at the unit circle. And we're going to I picked the domain values from 0 to 2 pi, broke them into fourths. So every fourth we're going to look at. We'll start with 0. So what is the sine of 0? Remember, sine represents your y value of the ordered pair. So sine of 0 is 0. Then we'll look at pi over 4. And all our fourths were square root of 2 over 2, square root of 2 over 2. So sine of pi over 4 is square root of 2 over 2. And we're going to be graphing this, so this is approximately 0.7. Then at pi over 2, the ordered pair there is 0, 1. So sine of pi over 2 is 1. 3/4, so 3 pi over 4 will again be square root of 2 over 2, which is approximately 0.7. Then over here at pi, we are at negative 1 comma 0, so sine will be 0 again. Then 5 pi over 4, we're now getting into the bottom half of the quadrant where y is negative. So this will be negative square root of 2 over 2, or approximately negative 0.7. At 3 pi over 2, this is 0, negative 1, so sine will now be negative 1. 7 pi over 4, that's negative square root of 2 over 2 still. And then we will be back at 2 pi, which is the same as at 0, so 2 pi is at 0. We're now going to take those values and graph them on the coordinate plane over here. We're going to break this up, so each one of these squares will represent a fourth. So this will be pi over 4, then we have pi over 2, 3 pi over 4, and then pi. And then we'll do that again on the bottom half of the unit circle. And so we have pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, and then 2 pi. And we're going to plot these points that we have here. I'm going to go and have every one of these represent a half unit. So we'll go 1, and on the bottom we'll go negative 1. And let's plot what we have. So at 0, 0, we have a point. So it crosses at the origin. At pi over 4, it's approximately, this is 0.5, so approximately 0.7. At pi over 2, it's 1. 3 pi over 4, once again, it's about 0.7. Pi, we're back at 0. And then at 5 pi over 4, now it's negative 0.7. 3 pi over 2 is at negative 1. 7 pi over 4, negative 0.7. And then 2 pi, we're back around the circle at 0. And if we continued this, we would be getting those same values that we have. So what we have is a nice smooth curve, and that represents your sine function or your sine wave. And once again, we could continue this graph over to the negative side of things. And so over here would be negative pi, and all that means is now we're working in this direction of the unit circle. So we're still going to follow those same values. At negative pi over 4, it's going to be negative 0.7. And then at negative pi over 2, it would be at negative 1. And then you'd be back at negative 0.7, and then back at 0. So this curve continues on in both directions, and it continues forever. It's going to keep going in both directions. So this represents the parent function for the sine graph. We want to become familiar with this because this is what we're going to use, and then we're going to add our transformations to it, and we'll move it accordingly and reflect it and things like that. So what are some things that we know about the sine function? Well, the domain, the graph continues to go left and right forever, so the domain will be all real numbers. You can plug in any value you want. The range, going back and looking at the range, you see that the max value is 1, and the minimum value is negative 1. So that's your range. And this is for the parent function. The period is how long it takes the graph to repeat. So if you go back, how long did it take the graph to repeat? Well, when we used our unit circle to find exact values, we had talked about this before, but it takes that entire full circle to start repeating. So the period is going to be from 0 to 2 pi. And then you can see when I went to the left, it starts to repeat there as well. This part and this part are the same. So that it starts to repeat. So a period in this case is going to be 2 pi. And then the y-intercept, you can see that it crosses. It actually started at the origin at 0, 0. And then your zeros of the graph, where it crosses the x-axis, sorry, wrong direction, but where it crosses the x-axis, you're going to see there are multiple places where the graph crosses the x-axis. Okay? So we will list a few of these, but we won't be able to list them all because it happens throughout the entire graph. So the first one we see in our graph is negative pi. So one of our zeros is at negative pi comma 0. We have another one at 0, 0. We have another one at pi comma 0. And then we have another one at 2 pi comma 0. So you can see there happen every interval of pi. So this is going to continue in this direction and in this direction in terms of what those zeros and how they occur. The other thing, it's an odd function. Remember, an odd function is symmetric with respect to the origin, so we can rotate this 180 degrees. F of negative x is equal to negative f of x, which in this case represents that sine of negative x. So when you plug in a negative x value, it's the same thing as the opposite of the entire function. Okay, so going back and looking at our graph, if we have an ordered pair of, let's just pick this one right here, of pi over 2 comma 1, then when we go and do that rotation around the origin, then we should have negative pi over 2 is the same thing as negative 1. So they both become opposite, and you can see that right down here that that's the case. So it's taking this graph and rotating it, and that makes it symmetric to the origin. And so that covers the different things that we notice about the parent function for the f of x equals sine of x. Now, there are 5 key points as we graph the sine function. We have the period as 2 pi. That's one cycle of the graph. It's broken into fourths. So you got 1/4. Here's the half. 3/4. And then a full period, which would be 1. So you also have the beginning point, which is 0. So that's where you get those 5 key points. It's either an intercept. So on this one, sine starts with an intercept. That's at 0, 0. Then at the quarter mark, it will go to the maximum value. Then it goes back to the x-intercept. Then at the third 3/4 marks, it goes down to the minimum, and then back to an intercept. So you can see that the intercepts occur at the beginning, the middle, and the end. So once again, the intercepts occur at the beginning, the middle, and at the end of the period. All right? In the 1/4 and 3/4 mark, you're going to have a maximum and a minimum. And once again, that just repeats as you continue your graph to the left or to the right. All right, now let's discuss some of these key characteristics of the function. So as you look at your equation, y equals d plus a sine of b times x minus c, where b has to be greater than 0, these are all your transformations. So use the same stuff that we did earlier with transformations. Now we're just applying it to a new function, in this case the sine function. But we still have our vertical and horizontal transformations. We still have our reflections. We still have our vertical and horizontal stretch and shrinks. So let's just kind of go through each of these and what they represent. The amplitude, which in this case is called the vertical stretch or compression, is the a value. Remember, that's the multiplier. When the y value or the function is being multiplied by something, that's changing the entire function. So the y value is changing. So that amplitude is basically your vertical stretch or compression. So this is where your max and mins will occur. That's that amplitude. So it's half the distance between the maximum and the minimum values of the range. The period. The period will represent your horizontal stretch and compression. That's going to have to do with this value in front of the parentheses, because if you multiplied the b inside here, it'd be b times x, which means you're multiplying it by the x value. So the x value is what's changing. So that would be similar to your horizontal stretch and compression. So to find what that period is, where in terms of how long the graph takes to repeat itself for that cycle, you're going to take 2 pi, which is the original period, and divide by that b value to figure out what the period of the new graph will be. Intervals happen in fourths, so once you figure out what the period is, you'll take the period and divide that by 4. And if you do the math here, it will equal, so you'd be taking 2 pi divided by b and dividing that by 1/4, or dividing that by 4, which is the same thing as 1/4. So this would be 2 pi over 4b, which would simplify to pi over 2b. Now I wouldn't memorize that. I would just think of it as the interval is the period divided by 4. But in terms of what it represents or what it is, it will be pi divided by 2b. Once we figure out the period in the interval, we'll then divide the period into 4 equal parts. Those will be your beginning, your middle, and end of the period. Remember your intercepts, that's the middle of the graph, and then you get your max is at the first quarter mark and your min is at the third quarter mark. So now let's discuss more about the transformations used to graph the sine function. So the A is your amplitude, but it also tells you whether the graph will be reflected over the x-axis. If the A is negative, once again thinking back to transformations, if the A is negative, then that is changing the y value. So therefore, if you're changing the y value, then it will be a reflection over the x-axis. The A is also your vertical stretch or compression. If A is greater than 1, it'll be a stretch. If A is between 0 and 1, it'll be a shrink. So your amplitude won't be as high on that one because it will be a vertical compression. The D value, this will be added to the function. So if it's added to the function, the y value is changing. So that will be a vertical shift up or down, depending on whether D is positive or negative. We also have the C value, which represents the horizontal shift because that's changing your x value. You're adding and subtracting that to your x value. So that's a horizontal shift left and right. And once again, if C is positive, it goes to the right. If C is negative, it goes to the left. Obviously, be aware if it is written as x minus C, that means C is positive. So that will go to the right. If it's written as x plus C, then C is negative and it goes to the left. So just a reminder about how that's written and looks. B is your horizontal stretch or compression. We're going to use that to determine our period, so we won't really physically be doing the horizontal stretch and compression like we did before. But just so you remember, it is a stretch if it's between 0 and 1, and it is a compression if it is greater than 1. We also multiply by its reciprocal, and that's why that kind of switches around there. All right, so those are really all the different characteristics and things of a sine graph in terms of the parent function, what characteristics we need to know, and then what transformations we will be using to graph the function.